The formation of Earth, the birth of a living world. Around 4.6 billion years ago, the young solar system was a swirling storm of gas and dust, an immense protoplanetary disk surrounding the newborn sun. Within this cosmic cloud, gravity began its relentless work, pulling tiny particles of rock and metal together. Over millions of years, these fragments collided and merged, growing into larger and larger bodies known as planetesimals. Among them, one future world began to take shape, the planet that would one day be called Earth. At first, this infant Earth was no more than a glowing ball of molten rock, constantly bombarded by asteroids and other debris. Every collision released massive amounts of heat, keeping the surface liquid and unstable. Heavy elements like iron and nickel sank toward the center, forming a dense metallic core, while lighter materials floated outward to create the mantle and crust. This process, planetary differentiation, marked a critical turning point, giving Earth its internal layers and setting the foundation for its magnetic field. As millions of years passed, Earth began to cool. A thin crust hardened on the surface, though it was far from peaceful. Volcanic eruptions were constant, releasing immense clouds of gas into the atmosphere. The early sky was thick with carbon dioxide, methane, and sulfur compounds, making it toxic and dark. There was no oxygen yet, no oceans, no continents, and certainly no life. But the chaos served a purpose. Volcanic gases and icy comets bombarding the surface brought essential ingredients: hydrogen, carbon, and water vapor. Slowly, as temperatures dropped, that vapor began to condense. For the first time in cosmic history, rain fell upon the Earth. It rained for centuries, perhaps for millions of years, until entire oceans formed, covering most of the young planet in deep, restless water. Amid these vast oceans, something extraordinary began. Within warm, mineral-rich pools and deep-sea vents, chemical reactions started to assemble complex molecules. From simple amino acids to more intricate organic compounds, matter organized itself in ways that hinted at something new, something alive. Around 3.8 to 4 billion years ago, the first primitive cells emerged. They were microscopic, fragile and simple, but they represented the dawn of biology, the moment Earth became a living planet. The early atmosphere was still oxygen-free. These ancient organisms survived by feeding on chemical energy, not sunlight. But around 2.5 billion years ago, a revolutionary transformation began. Certain bacteria evolved the ability to perform photosynthesis, to use sunlight to convert carbon dioxide and water into sugar and oxygen. Over countless generations, their activity flooded the atmosphere with oxygen, triggering what scientists now call the Great Oxidation Event. The skies cleared, the oceans changed color, and the chemistry of Earth shifted forever. This new oxygen-rich world allowed more complex life to emerge. For the first time, cells developed nuclei, forming eukaryotes. Eventually, they grouped into multicellular organisms. Life spread from the oceans onto land, evolving through endless cycles of adaptation and extinction. The Earth's surface itself was never still. Plate tectonics, driven by the planet's internal heat, shaped continents, raised mountain ranges, and carved ocean basins. Volcanic eruptions recycled materials back into the atmosphere, maintaining the delicate balance that sustained life. About 4.5 billion years after Earth's birth, something remarkable occurred. One small species began to look up and wonder how it all began. Humanity, made from the same stardust that built the world, started to uncover the cosmic story of its own origins. Scientists believe the Moon was formed early in this history, through a colossal collision between Earth and a Mars-sized body known as Theia. The impact ejected enormous amounts of debris into orbit, which eventually coalesced into the Moon. This event also tilted Earth's axis, giving rise to the cycles of day and night, seasons, and tides that shape life today. Over time, the sun stabilized and Earth found its place in the perfect zone, neither too hot nor too cold. Its magnetic field protected it from solar radiation. Its atmosphere trapped just enough heat to sustain liquid water. And within this narrow window of balance, life flourished in endless diversity. Mass extinctions came and went, asteroids struck, continents drifted, climates shifted, but life always found a way to continue. From microbial mats to vast forests, from ocean creatures to land mammals, Earth evolved into the world we know today. Every grain of sand, every mountain, every breath we take carries the memory of those first chaotic moments billions of years ago. The same atoms that once floated in a cosmic dust cloud now form our bodies, our oceans, our skies. The story of Earth is not just about geology or chemistry. It is the story of transformation, resilience, and emergence. Even now, our planet is still changing. The continents drift slowly across the surface, volcanoes reshape the land, and the climate evolves. Earth is not a static rock in space. It is alive, dynamic, and ever-evolving. And in the vast silence of the cosmos, among countless worlds still forming or dying, this small blue planet remains something profoundly rare. A world where the universe can look back on itself and wonder.